Okay, in the last video we introduced the concepts of domain and range, and now we're going to look at how to figure out the domain and range when you're given a graph, how to figure it out algebraically when you're given an equation, and in the next video we will look at how to figure it out when you're working on a word problem from the context of the question, because sometimes that can cause extra limitations on the domain and range. First, let's look at a graph. So this is a graph of y is equal to x squared. It's our standard parent function quadratic equation, our parabola that we're used to working with. And I've drawn in little arrows at the end to emphasize that the graph is going to continue to infinity in both directions. So if we wanted to know what the domain of this is, what we're asking is, well, what values can x take? So then it becomes important that there are these arrows here, because although the graph gets very, very steep and so is not going to be moving to the right very much, it will continue to go as far to the right as you want if you zoom out enough or if you follow it enough. Similarly, if you follow it as far as you want to the left, it'll just keep going and going. You could have x values of 1,000,000, 1,000,000,000, 1,000,000,000,000 in the positive direction or in the negative direction as well, and the graph will always exist there. So that means that x can be anything because it will go left and right forever. So again, the way we write that is we write a squiggly brackets, and then x is the funny e for element of, and then the funny r with the two backbones for real numbers, meaning x can be anything. Not really important that you put the two backbones, but you'll often see that. Now, so we know that as far to the right or as far to the left as we want to go, the graph will still exist there. So the domain is x is an element of real numbers. Let's look at the range. So the range is what values the y value can take. So again, we start off by writing y as an element of real numbers, and that's how we'll always start when we're using this kind of set builder notation. And then we write a vertical line such that and place any restrictions. And in this case, we are going to need to place restrictions because notice the graph will never go down here. So the y values in vertical dimension are never going to get below 0. The graph's never going to turn around and come back down. So the next question is, well, how low can they get? Well, at that point, the vertex is the point 0, 0. And it's that second 0 that's the y value. So the y values can get as low as 0, but they can never get lower. The way to write that would be y can be greater than or equal to 0, and then close the squiggly brackets because that's the end of our restriction. So y can be anything, well, not really. It can only be what is greater than or equal to 0, and that's how you would write this. Okay, next let's look at an equation. Here we have y is equal to 1 over x. And we want to ask first, what's the domain? So what values can x be? Now remember that to be in the domain, an x value has to give you a valid answer or a valid value for y. It has to make sense when you plug it into the equation. Remember that when we have fractions, we can never have a 0, or rather, we can never divide by 0. So the entire denominator of a fraction can never be equal to 0. And the entire denominator of this fraction is x. So that means that this x here cannot be equal to 0. Because if it were, we would have 1 over 0, which is undefined, and we don't want that. So the domain is, again, we start by writing x as an element of real numbers, such that, and x can really be anything else. As long as we've got either a positive or a negative number there, we'll get a valid answer for y. Now let's take a look at y. Again, we write y as an element of real numbers. Now, if x was a really big positive number, we would get 1 divided by a really big positive number would be a small positive number. Very small if x was very big. And if x was very negative, a very big negative number, we would also get a small negative number for y. But we'll never be able to get out a 0, no matter how big we make x. So that means that y can also not be equal to 0. So the domain and the range look similar in this case. In the next one, we'll look at how to restrict the domain and range for word problems.